Hello viewer, hope you've been doing good. I want to welcome you to our program Knowledge Quest on Hope Channel Kenya. I have been your physics teacher and we are going to proceed from where we stopped in the previous lesson. I just want to welcome you that you may join me, we learn together. Now in our previous lesson we made an introduction to force as a topic and we looked at a few things concerning force. We looked at the types of force that we have and we just made an introduction to some of the forces that we have. So we discussed about the gravitational force and we also looked at the upthrust force. And today we are going to continue looking at the other types of force which we have. So our subject here is physics and the topic that we are learning is force. And we are going to look at the types of force. We proceed from where we stopped last time. Today we are going to start from a type of force which is called the magnetic force. So this is where we are, magnetic force. Now, what is this that we call the magnetic force? That is what we are going to learn today. And probably we look at some of the materials which are related to magnets and then we stop it there for now. But I think in the later lessons that we'll do in the future, we're going to explore more on the magnetic force. Now, when we talk of the magnetic force, but remember a force is either a pull or a push from the introduction we made in the previous lesson. So that when we talk of the magnetic force, we are referring to the force of either an attraction or repulsion by a magnet. That is so to say that we have some substances which are called magnets. A magnet is a substance that is in a position of attracting a magnetic material. We'll understand that one as time goes by, but as at now, we say that the magnetic force is a force of attraction or repulsion. There are two things which are involved. We either talk of an attraction or a repulsion. And so when we talk of a force of attraction or repulsion by a magnet, then we talk of the magnetic force. A magnet is in a position of attracting some substances towards it, or at the same time, a magnet can repel certain poles of another magnet, and when we talk of that, that is what we call the repulsion. So the force of either an attraction, that means an object is pulled towards the magnet, or a repulsion, the object is pushed away from the magnet, then that kind of a force is what we call the magnetic force. Now a magnet, if we may look at it briefly, a magnet it constitutes of two poles. We have a north pole, so a magnet as a pole which we call a north pole, also a magnet as another pole that we call a south pole. Now a pole of a magnet is the end of that magnet. So that if I have a magnet, a bar magnet like what I have drawn here, one end will be a north pole, the other end will automatically be a south pole. So we say a magnet has some points we call the magnetic poles, and in these magnetic poles the force of attraction or repulsion is usually maximum around those ends. So the force of attraction will be maximum at the north pole or at the south pole, or if we are talking of the force of repulsion, it will also be maximum at the south pole or at the north pole. We say that when a magnet is brought close to certain substances, those substances will be attracted towards the magnet. And at the same time, when the same magnet is brought close to other substances, those substances may not be attracted. So we say we have two types of materials as far as magnets are concerned. So we can classify materials into two concerning the magnetic force. So we talk of number one, magnetic materials. We also talk of number two, non-magnetic materials. Magnetic materials are those materials which, when brought close to the magnet, or when the magnet is brought close to them, they'll be attracted by that magnet. So we say magnetic materials are attracted by the magnet. But when we talk of the other kind of the other category of materials, the non-magnetic materials, these ones are not attracted. The non-magnetic materials are not attracted, they are not repelled. They are not, the magnet has no effect on them. So those materials which are attracted are called magnetic materials. Those which are not attracted, neither are they repelled, are called non-magnetic materials. Examples of magnetic materials, or those which are attracted by a magnet, we have the following. We have iron, then we have another one we call nickel, we have cobalt, we also talk of steel. These four materials are all known as magnetic materials. When the magnet is brought close to where steel is, the steel will be attracted. When the magnet is brought close to a piece of iron, for example the iron filings, they'll be attracted. When a magnet is brought close to nickel and cobalt, they all be attracted, and because of that, all those materials are called magnetic materials. Now, some of those materials which we have listed there, the magnetic materials, are strongly attracted by a magnet, and those materials which are strongly attracted by the magnet are called ferromagnetic materials. But for now, we will not go deep into what ferromagnetic materials are. And an example of a ferromagnetic material is this cobalt that we have given here. It will strongly be attracted by a magnet. And some, like the steel, may not be strongly attracted. We just call them the magnetic materials. On the other hand, we have another category we have called the non-magnetic materials, those which will not be affected by the presence of a magnet. They not be attracted, they not be repelled. So examples of these materials, we have a piece of wood, we can talk of rubber, we can talk of plastic, among other materials. These materials cannot be attracted. We have a very important example, aluminium. Aluminium can also not be attracted, it cannot be repelled. Aluminium is a metal, but it cannot be attracted, it cannot be repelled. We also have copper, among others. All those are non-magnetic materials. They are not attracted, not repelled. Now, that is to do with the force of attraction, the first part of the magnetic force. So remember, we said magnetic force is the force of attraction or repulsion by a magnet, and we can classify materials into two, either magnetic or non-magnetic. What have we said? Magnetic are attracted, non-magnetic are not, so they are just there. Now if we bring two like poles, like we bring two magnets, a north pole close to a south pole of another magnet, these ones will attract each other. And so that is why we said that the force of attraction or repulsion, if we bring a north pole and a south pole close to each other, they will attract each other. But if we bring a north pole close to another north pole of another magnet, in this case, these ones will repel. They'll push each other sideways. So this repulsion also constitutes of a magnetic force. But in this case, repulsion can only take place the moment we have two like poles. Like we have a north pole and a north pole, or we can have a south pole and a south pole brought close to each other. They will not attract. We only expect them to repel sideways, and so the magnets will move apart. So when you talk of the force of either an attraction, that is if we have a north pole and a south pole, or a magnet and a magnetic material from any of those groups, that kind of an attraction due to a magnet, we call it a magnetic force. Or this repulsion force due to a magnet, we also call it the magnetic force. We have to be very specific here. We are saying the force of attraction or repulsion by a magnet. We can still have an attraction or repulsion by other substances which are not magnets. For example, when we talk of static charges in electrostatics. So when we are giving this definition, or when we are explaining the meaning of the magnetic force, this part here is very important. It is particular that it has to be by a magnet. If we are talking of an attraction, even unlike charges, that is a negative charge and a positive charge can attract. A positive charge can repel another positive charge. So we don't just talk of the force of attraction or repulsion. We have to specify that by a magnet. If it is not a magnet, then it's not magnetic force. We have another kind of a force. So this is ideally what we call magnetic force, and it's just an introduction to what magnetism is. We later on go more into details concerning the magnetic force. All you need to know as a learner is what magnetic force is, how where it comes from, and how it is exerted. That if there is a magnetic material, it will be attracted. If the material is non-magnetic, the magnetic force has no influence on it. This magnetic force has very important applications. For now, we can just mention a few. Like we talk about radio speakers, we talk about telephone receivers. All of them make use of a magnetic force. So let me talk of a moving coil loudspeaker, and then we talk of a telephone receiver, in our mobile phones. All of them make use of this magnetic force. They have small magnets. The loudspeakers in the radios, in the woofers you have at home, they have small magnets which we call the ring magnets, and even the telephone receivers also have small magnets. And ideally that is why we are learning of the magnetic force. In physics we do not learn something if it doesn't have an application. Everything we are learning, all the forces we are discussing here, have applications in the surrounding, in our homes and in any other place, in the workplaces, in schools, and in every other place. That is why we are learning them. So for now, that is what we call the magnetic force. I just wish that we go to another type of a force. Next we'll talk of the friction force. Now, friction force is a unique kind of a force that can only come into play the moment we have motion, or the moment we have relative motion. When we talk of the friction force, here we only talk of a force that comes into play when we have two objects which are in contact and there is a relative motion, when one of the two objects tends to move. For example, let's consider a wheel of a car on the road, and the car is moving from one point to another on the road surface like that. Now, if the wheel is moving in that direction to the right, there is always another force that is exerted on the wheel in the opposite direction, only when the wheel starts moving. If the wheel is not moving, that is, if the vehicle is at rest, then this second force that is acting in the opposite direction, or what we call the friction force, will not be there. So we say friction force is a force that tends to oppose relative motion between two surfaces when one surface tends to move. That is very important for us. that the friction force is only there the moment there is a relative motion. If the two objects are in contact, like I place this eraser there, I'm not moving it, there's no friction force. It only comes into play when I tend to move the duster downwards or to the right or in any other direction. So this friction force that that acts between two surfaces which are in relative motion acts in such a way that it opposes the motion. This friction does not come into play to encourage the motion. It does not come into play to increase or to enhance the motion. It usually opposes the motion. So because of that, the friction force always is in the opposite direction to which the object is moving. So if we have a block of wood on the surface of a table or on the floor, if the block is pulled to the right, if you exert a force pulling it to the right, then there will be an opposing force on the block of wood. This is the floor, and this is the wood placed on the floor. So if we pull the wood to the right, the friction force will come into play and it will move, it will be directed to the left, and so it's always in such a way that it tends to oppose the motion of that particular wood on the floor. Usually the friction force varies depending on a number of factors. Friction force will vary depending on, number one, the nature of the surface. So if the surface of the floor here is very rough, the friction will be more. If the surface is smooth, the friction will be less. So friction will depend on a number of factors. Number one, we talk of the nature of the surface. So a rough surface will produce more friction compared to a smooth surface. So if we wanted to, like for example, if you look at the nature of the wheels of a vehicle or the tires of a car, they are usually made in such a way that they have threads. And why are they there? That is so to increase the friction force between the tire and the ground, and that friction force is what produces a forward thrust to make the car to move from one point to another. Now that later on we are going to mention a few applications of the friction force, but for now let us have it that friction will depend on the nature of the surface. The rough the surface, the more the friction. The smooth the surface, the less the friction. Now number two, again, the friction will depend on something we call the normal reaction, or what we can easily for now say depending on the weight of the object. Now, if an object is very light, the weight of the object, if the object is very light, the friction force will be very small. For example, just think of a piece of paper placed on the floor. A piece of paper, a sheet of paper on which we write. You place it on the floor and then you pull it on one direction. You may not require a lot of force. Now compare that one to a heavier object. For example, you have a wheelbarrow which is loaded and you are trying to push it from one point to another. You realize that we require more force to push the wheelbarrow compared to pulling the small piece of paper. What makes the difference is the weight of the two objects. Now, the heavier the object, the more the friction it's going to experience, and the lighter the object, the less the friction it is going to experience. So friction depends on two very important things. Number one, the nature of the surface. If the surface is smooth, the friction is less. If the surface is rough, the friction is more. Then number two, the weight of the object, or we call it the normal reaction, because the normal reaction usually is equal to the weight of the object. If the normal reaction is more, then the friction force will also be more. If the normal reaction is less, or if the weight of the object is less, the friction is going to be less. That is what we have there. Now this friction force, this force that opposes relative motion between two surfaces in contact, is very important when it comes to applications. And let me give us a few applications of the friction force. I think now this is the most important part of it, and that is why we are learning of the friction force. Number one, friction force is what makes it possible for you and me to walk. So friction is very important when it comes to walking. If friction was not there, then it is not possible for you to move from one point to another. It will not be possible for me to move from one point to another. It is not possible for us to walk in the absence of friction. Just think of, why do you think is it that when you are running and the road is slippery, why do you slide and fall on the road or in a muddy place? It is because when the road is slippery, the friction is reduced, and so the forward thrust is not enough to keep you moving forward, and so you are not going to move comfortably if the friction is reduced. Then number two, friction is very important when it comes to braking. Assuming you are riding your bicycle or you are driving your car and you want to stop it, if there was no friction, it is not possible for you to stop. If there was no friction, it is not possible for you to slow down. You will continue moving in a straight direction or in whichever direction you are moving, and that is not very good for you. So for us to achieve braking in vehicles or in the bicycles when we are riding, then friction is very important. That is one application again. Then number three, friction is very important for us to light a matchstick. If we wanted to light fire and we have a matchbox and a matchstick, we only need friction to be present when we are striking the matchstick on the matchbox for us to obtain the fire. So it is very important. Again, it's an application for that one. And then we use friction to sharpen. Friction is used for sharpening. Now, these are some of the applications or the advantages of the friction force that we are having, and you can agree with me that all these applications are very important. Just imagine if you are not able to walk. I don't think it will be very nice. Imagine you have a car but you cannot brake. Then that car will not be useful. Or you have a matchstick and a matchbox but you cannot light, then the matchbox is equally useless. Or you have a knife and you cannot sharpen it. All these are applications of friction. So friction is a very important force to us, and so we need it very much. But at the same time, friction can be a nuisance. Friction can be very disadvantageous. Friction can also lead to unwanted observations. Number one, these are some of the disadvantages of the friction that we have. The first one, it can produce unwanted noise. Now, just recall if you have ever pushed a wheelbarrow which is not greased enough. So when you are pushing it and the load on the wheelbarrow is so much, then it can lead to some of the things which I'm about to list here. Number one, it can lead to unwanted noise. For example, you are braking and due to the motion between the parts of the brake parts of the vehicle, you just realize that it is producing a lot of unnecessary and unwanted noise. That is a disadvantage. Then number two, we talk of it can lead to wear and tear of the parts of a machine, and that is also not very good. Number three, it wastes power. In other words, it reduces the efficiency of machines. Like when you are pushing a loaded wheelbarrow or you are pulling a cart which is loaded, you require a lot of force. These are some of the disadvantages of the friction force. We can reduce friction, that is, we can overcome these disadvantages by reducing friction using two different ways. Number one, we can use rollers, and number two, we can use lubrication. So if we wanted to do away with these disadvantages, you have two ways. Number one, you can talk of lubrication. Then number 2, you can use rollers, among other ways of reducing the friction. So that is what we have for now concerning the magnetic force and the friction force. We're going for a short break. Let's meet right after the break. Welcome back. We are going to proceed with our lesson, and now we are going to introduce another kind of force that we call the adhesive and the cohesive forces. There are 2 different types of forces here, but we usually discuss them as one. So the adhesive and the cohesive force is what we have for us to discuss. Now, when we talk of the adhesive and the cohesive forces, what we are going to look at is something very simple, but we are going to use water and glass slides as examples for the illustration of what we are going to discuss, and then we shall generalize and give a conclusion. Now, what we need here to make as an observation, is we need some 2 glass slides, one which is clean and another one which is waxed, which is not clean on the surface. So this is a clean glass slide, the usual glass slides that we use in the lab, and then we have a waxed glass slide on the other side. Then we need some water, and also we need some mercury. For now, these are the requirements that we need. So we need a clean glass slide, a waxed glass slide, we need some water, and then we need some mercury in a container. Sometimes we may not do this experiment because mercury is not very friendly, so that is why we prefer to do a theoretical. We just give an explanation of what we are expected to make as the observations. As it is, we may not give you in the lab or in class, we may not give you mercury to use for the experiment. It is not very good to you as the learner. And if we can use only water and without mercury, then it's as good as we can do a theoretical explanation, and that is what we want to do here. Now, what we are going to do is very simple. We take a few drops of water. This is water in a beaker, and then we have mercury down here in another container. We take a few drops of water and then we sprinkle on the surface of the clean glass slide, and also we take a few drops of water and we sprinkle on the surface of the clean glass slide. When we are done, we repeat the same experiment. We take a few drops of mercury, we sprinkle on the surface of the clean glass slide, and we also repeat, we take a few drops of mercury, we sprinkle on the surface of a waxed glass slide. For each of those 4 parts, we are going to make different or similar observations, and this is what we are likely to make as part of the observations. Now, when we sprinkle water on a clean glass slide, this is what we are likely to see. So for water on a clean slide, this is what we see. Let me draw the surface of the slide just that way. On the surface of a clean slide, water will spread on the surface of it, will form oval-shaped drops. But when we consider a waxed surface or a waxed slide, water will not form oval-shaped drops. It is going to form drops which are spherical. It will form small perfect spheres on the surface of the slide. And from these 2 observations, we can go ahead and come up with the definition of the adhesive forces and the cohesive forces, and we try to illustrate and explain what they are. Now, if you look at the clean glass slide and the other one is a waxed slide, on a clean slide, water will tend to spread. This simply means there is a force that is attracting the molecules of the water in this drip in this drop, so that they keep moving or spreading outwards, sideways. It simply shows that there is a force that is attracting those molecules and they move sideways. But in the second one, that force is missing, or the force is weak. It is not as strong as it is in the first slide here. Now for the second drop, the same thing. That force that keeps attracting the molecules of the drop so that they move sideways is weaker here compared to that drop on the previous clean slide here. Now we say this. Adhesive force, by definition, is the force of attraction between molecules of different kinds. You have to get this. When we talk of the adhesive force is the force of attraction, between molecules of different kinds. You have to note this word here. We are talking of molecules of different kinds or different types. Like now, if you look at the first glass slide, you will see that water, as much as it is a drop, yes, but this drop is made of several molecules of water to form that drop. This drop of water comprises of several molecules of the water itself. Remember, water is made of small molecules. And when you look at the second object below it, the glass slide also is made up of several molecules below here. Now there is an attraction between the molecules of the slide and the molecules of water. That is to say that the small molecules of water up here are attracted by the molecules of the slide down here. The same case on the other side, this molecule of water is attracted by the molecule of the slide. On the other side, for the second drop, the same thing. The molecules of water are attracted by the molecules of the slide here. This force of attraction between the molecules of water and the molecules of the slide is what we call the adhesive force. Here, the molecules of water are different from the molecules of the slide. That is why we are saying that it's a force of attraction between molecules of different kinds, because we have water and we have the slide. The slide is made of glass. So because this is glass and that is water, we talk of the molecules of different kinds, and so then the force is called the adhesive forces. Now for the first slide, the adhesive force is very strong. Now on the other side here, we also talk of the cohesive forces. The cohesive force is a force of attraction, yes, just like the adhesive force, but now this force of attraction is between molecules of the same kind. You see, for both the adhesive force and the cohesive forces, we are talking of a force of attraction between molecules. But now the key word here is, for the adhesive force, we are talking of the force of attraction between molecules of the same kind, of different kinds, like we have the water molecules and the glass molecules. Now, when we look at the force of attraction between molecules of the same kind, for example, now look at the second slide, we have molecules of water, so many of them. Now here, the cohesive force, that is the force of attraction between water molecules, is so strong compared to the attraction between the molecules of the slide and the molecules of the water. Now what happens is, when wax is applied on the surface of the slide, the wax reduces the adhesive force. When the adhesive force is reduced, when it is weakened, the cohesive force becomes stronger, and that is what makes the shape in the second slide to be spherical, like what we are seeing on the drawing here. So we say this, that if we were to give a definition of the two forces, that is exactly what we have said. Adhesive forces are forces of attraction between molecules of different kinds. For example, water molecules and glass molecules. But cohesive forces are forces of attraction between molecules of the same kind. Like now here we consider only the water molecules, this molecule and that one, this one and that one. On the second drop, we consider this water molecule and that one, this one and that one, etc. And now for the second slide, the cohesive forces are stronger than the adhesive forces. That is why we have this shape of the drops on the slide. They are spherical. But for the first one, the adhesive force is much stronger compared to the the adhesive force is much stronger compared to the cohesive force, and that is why the drop spreads on the surface. So for the first observation, this is described as, we usually call it that the water wets the glass, but for the second one we say it does not wet the surface. So a clean slide, water we usually wet a clean slide. This term here, to wet the clean slide, simply means water will spread on the surface of that slide. So the wetting we are talking of is spreading. But for the second observation, water does not wet a waxed slide, and does not wet here means it does not spread, but instead it forms spherical shapes, drops, and that is what we are exactly seeing here. Now that is for the first case when we use water, but we can do the same using mercury. Now for mercury, it is much simple that we irrespective of the slide we are using, whether it is clean or whether it is waxed, mercury will form, for all, whether it is waxed or not, it will form spherical shapes of the drops which are going to be formed there. Mercury does not spread on the surface of the water of the slide. Mercury, in other words, we say, does not wet a slide. And why is that the case? Now for this mercury, for all the cases, the cohesive force is usually stronger than the adhesive forces, and because of that, mercury cannot wet the slide, cannot wet the surface of a slide. So these are the two illustrations that we can use if we were to do the experiment in the lab to demonstrate the adhesive and the cohesive forces. Now all that we need to know as at now is what the adhesive force is. The adhesive force is the force of attraction between molecules of different kinds, and the cohesive force is the force of attraction between molecules of the same kind. When the adhesive force is stronger compared to the cohesive force, like in the case of the clean slide, water will wet the surface. When the cohesive force is greater than the adhesive force, water does not wet the clean glass slide. But for mercury, in all the cases, the cohesive force is usually greater than the adhesive force, and because of that, mercury does not wet the surface of the slide. That is what we call the cohesive and the adhesive forces. We can still demonstrate these adhesive and cohesive forces using narrow tubes and water in a beaker, or mercury in a beaker. Let me draw something different here. Again, I try to illustrate the same for you to have a better understanding of what we are talking about. Now for this second one, we need some narrow tubes of different sizes, and then we also need two containers, one having water, another one having mercury. Now let me use the first beaker here that is containing water, and then I have two narrow tubes. One is narrow that way, another one is a bit wide, but it's also a narrow tube. Also I have another container that is having mercury. I also have the two tubes, one is narrow, another one is not very narrow, like that one. So the question is, when we put water and here we put mercury, how are the levels of the liquid going to appear in these narrow tubes? This is narrow tube 1, this is tube 2. For mercury, this is tube 1, that is tube 2. How are the levels going to look like? Are they going to be the same across, or there will be a variation? The expectation here is when we put water, the level of the water will be different outside the tubes than inside the tubes. Usually the level will be highest for water, the level will be highest in the narrowest tube, and then it will be a bit lower for the tube which is slightly wider. But for both the tubes, tube 1 and tube 2, the level of the water inside the tubes is usually higher than the level outside. The level outside is this one here. Let me make it very bold. This is the level outside the tubes. Usually the level inside, for tube 1 it is here, for tube 2 it is there. Usually the level inside the narrow tubes is higher than the level inside. Why is that the case? Just like what we did previously, for water, the adhesive force is greater than the cohesive force. And so these adhesive forces will attract the molecules of water upwards, and so more of the molecules will tend to be in contact with the walls of the tube, and because of that the level will rise inside the tube. So the rising here inside the tube is because the adhesive force is greater than the cohesive forces for water. Now when it comes to mercury, for mercury it is exactly the opposite of that one for water. The level of the meniscus outside the tubes will be lower than the level inside the tube. So this is, if at all this is the level outside the tubes, the level inside will be lower compared to the level outside the tubes. Usually the level is lowest in the narrowest part and highest in the widest part of the tube. And like for water, the level was highest for the narrowest and then lowest for the widest part or the widest tube which we are having. Even if there are 3 or more, the level will vary depending on the dimension, the cross section of the tube. So for water it will rise up, but for mercury it will be dropping, it will be decreasing, it will be going downwards. That is the opposite of what we said for the water. Why do we have the two observations? For water we have just said that the adhesive force is greater than the cohesive force, and the adhesive forces will tend to attract the water molecules so that the molecules move up the tube. This molecule is attracted by the molecule of the glass, and so they keep moving upwards, and that is why the level is higher. The same case for that one. But for mercury, the cohesive force is stronger, is greater than the adhesive forces. Remember, the cohesive forces are the forces of attraction between molecules of the same kind. So the molecules of mercury inside the tube will be attracted by the molecules outside the tube, and so that force being stronger, it pulls the molecules to move downward so that they cannot go up the tube. They can only go up the tube if the adhesive force was stronger, but now this is not the case. The cohesive force is greater, so it will tend to attract them, and so they come together. So the molecules of mercury inside the tube are attracted and they come to their neighbors, the neighboring mercury molecules, and so they move downwards. That force is greatest because these molecules are less in the narrow tube. That force will have a greater influence because they are few, they'll just be pulled more compared to this wider part here where the molecules are many. The same force of attraction, because it's spread across many molecules, it will not be as strong as it is in the narrow tube, and so that is why the level is lowest in the narrowest tube and then highest in the widest part or in the widest tube which we are having there. So for mercury we are simply saying that the force of attraction, that is the cohesive forces, are stronger than the adhesive forces, and that is why we have that kind of an observation. So whichever way, this experiment and the other one we started with, we usually say that the cohesive forces are forces of attraction between molecules of the same kind, and adhesive forces are forces of attraction between molecules of different kinds. Sometimes we do make use of applications of this adhesive and the cohesive forces. For example, we talk of the damp courses that are placed above the foundations in the case of construction for buildings. You must have seen some, if this was the foundation of a building, before the wall is constructed up here, there is usually a damp course. There is a piece of a nylon paper that is placed there. You see, because of the adhesive forces, water will tend to come up from the ground to the foundation, and then from the foundation up the walls, and so to prevent the water from rising up to the walls, thus weakening them, a damp course or a damp material is usually placed above the foundation to discourage this upward movement of water, something that we call the capillary or the capillarity or the capillary action. So that is so the capillarity takes place because of the adhesive forces. Among other applications, we have the lantern lamps we use at home that make use of kerosene, and then there is a wick that is immersed inside the kerosene. Now, how does the kerosene rise up from the reservoir down here up to the point where you are lighting on top? it is because of this force of attraction between molecules of different kinds, or because of what we have called the adhesive forces. The kerosene molecules are attracted by the molecules of the wick, and so it moves up to where it is going to be burned at the top. And so that is an application of the adhesive and the cohesive forces. So what we have just learned for our lesson today, we have looked at the magnetic forces. Just remember, magnetic force is the force of attraction or repulsion by a magnet, a very important thing. And so you can remember the applications we mentioned there, like in a loudspeaker or a moving coil loudspeaker or a telephone receiver. We also talked of the another force, the friction force, the force of that opposes relative motion between two surfaces in contact. Most importantly, the applications, like in the walking, braking, lighting a matchstick, sharpening, etc. And also you can recall that we talked of ways of reducing the friction. Friction can be a nuisance, so we need to do away with friction sometimes in places where we do not need it. How can we go about it? We talked of using lubricants, or what we call oiling and greasing. We can use rollers. Sometimes it also helps in reducing the friction. And also we have talked of the cohesive and the adhesive forces. Adhesive forces are forces of attraction between molecules of different kinds, and cohesive forces are forces of attraction between molecules of the same kind. And also just remember a few of the things we have discussed here and their applications. Up to next time, I've been your teacher, Peterson Maranga, taking you through physics. Our topic has been force, and we shall continue from there next time on Knowledge Quest Hope Channel Kenya. Thank you for watching us. Stay tuned. Get blessed. See you next time.